Now, if you had went through theorem 10, you would come to realize that it does have actually a converse. So we are going to look at that converse, the converse of theorem 10. Now, what this theorem says is that if the square of the longest side in a triangle is equal to the sum of the squares of the other two sides, then the triangles are right angled. So now we're saying here, if you take any triangle, and such as this one here in this diagram, we have any triangle PAT, and in this triangle, when we measure this side and we square it, we find that it's the same as the sum of the square of these two sides, meaning we measure this one PAT, we square it, and we add it to AT, we square it, and we find that this become equal, meaning the square of this becomes equal to the sum of the square of these two other sides. Then we really can conclude to say this triangle must be a right angle triangle, because really when we did the theorem, we started with a right angle triangle, right? And we concluded this result. So if we have this result as our starting point, as what we are given, we must be able to conclude that this is a right angled triangle. And how we write this theorem in short, we simply say is the converse of the theorem of Pythagoras, or you can simply say the converse of Pythagoras. Again, just to emphasize the fact that, when we write this in short, we do not use the A part and the B part, because, the A part in this case is the fact that we know this relationship between the sides of this triangle, then we can conclude that it is a right angle triangle. And further to add on that, this converse becomes very important if you want to classify, or if you want to find or prove that the triangle is a right angle triangle. Prove that the sides are having this relationship, then you will be able to then know that that type of a triangle is a right angled triangle.